What's going on, guys? Let's see how to prove this proposition using well-ordering property. Here the proposition says for all x belongs to natural number 3 power x is greater than or equal to 1 plus 2 power x. Okay, here what we are going to do is we are going to take the contradiction of this one and prove that contradiction is wrong. If we can prove the contradiction is wrong, then it automatically means this proposition is proved. Okay, now let's go ahead and write the contradiction. The contradiction of this one is going to be there exists, because if it's for all, the contradiction is going to become there exists a k. There exists should be opposite e sign. This one should be opposite. There exists a k belongs to natural number where 3 power k is less than 1 plus 2 power k. Okay, now we are going to prove this one is wrong. If we can prove this one is wrong, then we automatically prove the opposite is correct. That is the original proposition. Okay, so first we are going to set a set that s is equal to a belongs to natural number where 3 power a is less than 1 plus 2 power a. I just sampled this one right here. 3 power k less than 1 plus 2 power k. I sampled it as 3 power a is less than 1 plus 2 power a. Now we know that s is not an empty set because it belongs to natural number. S is not an empty set, and also because it has a k in it, because k belongs to s. Because k belongs to s. Also s is bounded below by 0 because it's a natural number. Also s is bounded below by 0. So by well ordering property, s has a minimum. By well ordering property, s has a minimum. S has a minimum like, let's say m is equal to minimum of s. Now this means the same things should be applied for the minimum too. So minimum mean 3 power m is less than 1 plus 2m. Now here we are going to show that m minus 1, like m minus 1 also belongs to the set, but this is a contradiction because m is the minimum. It means m minus 1 cannot belongs to the set. If we can prove this one comes for m minus 1 also, this thing come also m minus 1 also, then we prove this proposition is wrong because m is the minimum one and m minus 1 is not in the set. And if we can prove this one also satisfy this one, then it means this proposition is wrong. Okay, now let's go ahead and prove this one. First we are going to say m minus 1 is less than m, because we are subtracting 1. M minus 1 is less than m. M is the minimum set. Okay, now we are going to apply the same thing for this one, 3 power m minus 1. We put that one for this one. Now the next thing is like we have 1 power, like we have 1 and 2 power m this side, right? If it's m minus 1, it means we are dividing this one by 3. So we have to do the same thing for this 2 side row, right? 2 side row. Now the thing is, when we have to show the final pattern similar to this one, we shouldn't have this 1 over 3, like we shouldn't have this 2 power m over 3. We have to bring everything in terms of 3 power m less than 1 plus 2 power m. And if we can show that one for this also, this minimum, less than minimum, it means we prove this proposition wrong, because we know that minimum, it should only satisfy for minimum, but it shouldn't be satisfied for something that's less than minimum, because that's not in the set. Okay, now to bring this one into this pattern, you can notice this 1 over 3, here we had to just take a guess. 1 over 3 is definitely less than 1, right? So instead of 1 over 3, I put 1 right here. And 2 power m over 3 is definitely less than 2 power m over 2, because this is we are dividing this one by a bigger number. If we divide this one by smaller number, this is gonna be like this, right? So if we rewrite this one, 3 power m minus 1 is less than 1 plus 2 power m minus 1. Now we prove this one. We proved that something less than minimum also satisfies this condition. So m minus 1 belongs to the set. This is a contradiction, because m is the minimum value the set has, and m minus 1 also belongs to the set. It means it's a contradiction. It means the contradiction is wrong. It means we proved the original proposition. Okay, I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.